All right. Today we're going to be working on determining the mean or the median and which one is appropriate to describe the center of the data. So like 3 weeks ago, we would give you a dot plot and we would say, hey, what's a typical value? And you looked at your data and you picked kind of the middle or you picked the highest frequency, and that was your description of center or typical. Now you know 2 more calculations, okay? You know the mean or the average if we added all of those up and divided them equally. We also yesterday learned about the middle value. Today you're going to be able to determine which one to use and which one's a better description. Okay? It's a hard day. You're going to be thinking a lot. So I need you like locked in. Cool? All right. Here are 2 data dot plots. The first dot plot shows the heights of the first 22 U.S. presidents, and the second one shows the heights of the next 22 U.S. presidents. We are not actually going to do the math. We're going to say if we agree or disagree, okay? The median height of the first 22 presidents is 178. So looking up here, what do you think the middle value is? 178. Why would you say 178? Trevor? Good. It's in the middle. Can you kind of tell that if we were to start ticking these off, where would we land? 178. And it technically, we actually did tick them off in the first class. And it was yeah, it really is the middle. It has the same number of data values, less than and greater than 178. The mean height of the first 22 presidents is about 183.
Yeah, that's right.
So the mean is the average, meaning if I add up all of these centimeters and distribute them evenly, would you say your balancing point would be 183 right here?
Yeah, probably.
Do you think that would balance your data?
Yeah, maybe.
Do you think it pulls it a little bit more? Do you think it should be a little bit like 180?
I feel like yeah.
Good. So
because there's the same height to the left, and there's more data points to the left than to the right.
okay, so we have more data points. What will happen with even this guy right here? That balancing point is going to be pulled down a little bit more than 183. 183 has it's equal with the highest frequency. But wouldn't these kind of cancel each other out? And then you'd look at where your data is being pulled. A typical height for a president in the second group is about 182. So looking at right there, 182. Do you think that's typical? Give me a thumbs up or a thumbs down. Do you agree with that statement? I got one that went up and then we went back down. What are we thinking? Typical. Okay. Would you have argued 183?
Or 181.
181. So maybe somewhere in there. Are those still pretty close to 182?
Mm-hmm.
Yeah, I think you'd have to agree with that one. U.S. presidents have become taller over time. Agree or disagree?
Yeah.
U.S. presidents, give me a thumbs up, thumbs down. Have they become taller over time from your 1st through 22nd and then 23rd through 44th? Okay, why do you say yes, Gabe?
Because in the 1st to 22nd president, there's more of smaller presidents from around 125 to 162, but this one is more on 105 to
Okay. This one kind of reminds me of your typing speed. You remember when we did that 1 minute typing speed? And the teacher wanted to determine that the typing lessons helped them improve.
Yeah.
Okay. How did we show that? Yeah, they did improve. Where did the majority of our data points kind of shift to? Did they shift up from our first one? Yeah. They would kind of say that maybe on average they would shift up a little bit higher. So I would say, yeah, we agree that they have become taller over time because more consistency, more data points are right there, looking at that concentration. Then when you had some data points that were here, you had a group here. Even looking at your least has even increased. I don't know, are people getting taller with time? It's weird. The heights of the first 22 presidents are more alike than the heights of the second 22 presidents. The heights of the first 22 presidents are more alike than the heights of the second 22 presidents. So are they more alike? Trey, what do you think of?
Not really, because it's the second one or the first one?
Who's more alike?
The second one.
Okay, so our second one, presidents have more alike. Why do you think that? Good. We have a narrow spread and we have a much wider spread. We still have these little guys over here and we even have that little guy back there, but consistently our presidents are more clustered together. So this number 5, the heights of the first 22 presidents are more alike than the heights of the second 2. We would say we disagree with that. And leading to our next question. The MAD of the second data set is greater than the MAD of the first data set. So we got to review what MAD is, the mean absolute deviation. So if we think about, just to draw a picture, if we think about our balancing point, our deviation was how far away on average our points were. So if this deviation had a deviation of 5, we said that our points were kind of more spread out versus if we had a deviation of 1, where would more of our points be?
It's a narrower spread, and then the greater the map, the wider the spread is.
Okay, so which one's going to have a greater MAD, the first or the second? Who has more data points further away, Rylan? Yeah. Good, we got like a wide spread happening here versus our second one kind of have it a little bit more together, which just means that our data points are more consistent. We always talked about basketball shots with this one. Like, who do you want on your team? We remember? Yeah. Okay, so we talked a lot about MAD when we were talking about accuracy and consistency. Okay. We are going to be using the data points from one of the questions, which was how tall our class was with shoes on. So it says up here, your teacher will provide some height data for your class. Use that data to complete the questions. Find the mean height of your class. So I'm going to have to write down every one of the numbers that are on the sticky note, and I'm going to yell them out. But I need somebody to write them up here, along with somebody in each group to write them down, okay? So I'll probably have whoever is in blue write them down for me. We don't have anybody that invited today, right? I mean, nobody extra. Cool. Besides Casper.
Casper, go.
I'll share my pen with Casper. We have one activity up at the board. You'll also notice that there's calculators. What computation am I going to need calculators for? The mean or the median? Raise your hand. The The mean or the median? Which one am I gonna need a calculator for? That would make it a lot speedier. Isabel? The mean. Why?
Because you have to add them all up and then divide.
Yeah. Do yourself a favor. Once you've added them all up, write it down on the board. So in case you make I divided by the wrong number and now we have to start over. You're not starting all the way over.
What are we going by?
Color. Is it color? Or is it shape? Or is it number?
Yes.
Ding, go. Green, orange, and blue, you only have 2. Jace, I'm gonna have you write up here. We're gonna write them in purple. You're gonna write them all right here, okay?
Okay. Like in order, like from.
Nope, just as I yell them out, you're gonna write them down.
Okay.
All right, grab the marker, we're gonna get started. Not the calculator, Brinley, grab the marker, we're gonna get started. I am going to yell out the numbers. The person with the marker, you just have to write them all down. Don't try to put them in order while I'm yelling them out. Got it? Yep. Okay. 155. 153. Pause on a marker switch. Throw that one away. Alright. Alright, 159. 155. 160. 144. 163. 149. 160. 155. 150. 145. 147. 161. And 146. All right, mean and median, and then stop.
Mrs. Edwards, do I do it up here as well? Yeah, 144. Wait, what do you say 144? Oh. 144, 146. Or no, 145, my bad. 149. 155 There's no 150. Oh yeah, there is.
151. 150, 150 equals how many there's no 1, 2, 3, 4, 5, 6.
Over there, I think you saw 160.
Oh yeah. I saw it. 150. No, not 153. 155. 155. I got 15. 155. No, 3. 1, 2,
You write down 153.
no, yeah, 3.
159.
Wait, there's 2 160, so there's 2 169. Wait, there's a 151.
Yep, that's me.
Probably should bounce the meme before we cross the wall.
Just a double check. 2, 3, 0, divided by 15.
Where do you guys see 153 at? No, 153. How many 153?
No, I'm 7. 7.
Alright, 155. Just 149. I have to divide by. So
'Alright, do we have the mean? What's the next thing? Find the median. Go ahead and list them in order. Find the median.
Hold on.
Well, you have two to be added together. You just get one, that's your main.
No, it's not 5.
What?
It's a 3. Okay. There's an odd number.
With the mean, it just depends on how you round, because it's like 4, 6, 6, 6, 6, 6, 6, 6.
That's correct.
To the nearest hundredth is good.
1, 2. Can we do the other one, the 3?
Pause on 3.
Pause on 3.
That's the middle. Alright. Are we, oh, they're still doing, are you guys done? Okay, you're writing them in order. Okay, if you have figured out your mean and your median, come stand in the middle so I know if you're done.
15. We have 15.
Yep.
That doesn't count as 1. No, it doesn't. Trust me.
Oh my gosh.
Trevor is getting
Alright, start crossing them off. Maybe one of you goes on the end and the other goes on the other end. Don't erase them though.
Scott and Cal. No.
the rope doesn't go fully around.
varsity, did you go to a varsity game against Coal City last night? The baseball?
No?
Okay, so if you have 15 numbers, you should have a middle, right? If you have 15 numbers, you should have a middle.
40 by 40 there in baseball? No, they got cooked like 8 or 11 to 3. Coal City's good at every sport.
Yes.
All right. The mean, I see 153 and 46 hundredths. We have a mean about the same.
Yeah, we rounded to the nearest one.
Perfect, rounding to the nearest hundredths, great. The median. So wait, pause. Our mean was 153 and our median was 155. Do you think those are pretty accurate?
Yeah.
Yeah, okay, so around 155, that's awesome. Now, we're gonna add a new student. We have the world's tallest adult, who is 251 centimeters. Now, how am I going to incorporate this new person without starting all the way over? Let's talk about the mean. How am I going to find my new average? What do I need to do, Nora?
Can you just add 251 to it?
Yeah, I need to, what was the number? Because I told you guys to write it down before you.
2,302, I think.
2,302? Perfect. So then you can walk back to your station, but I'm still going to be teaching. When we add in our new person, 2,302 plus 251.
Wait, it's 2,553.
I got a new mean.
Hold on, pause. So somebody said that once we added them all up, it was 2,302. I see that on multiple things. I'm going to go with that number. Okay, then I'm going to add these together. So now my new total amount of centimeters is going to be 2,553. Pause. What am I dividing it by?
16. No, 16. No, 16.
How many people then are in our class?
16. There was 15, now there's 16, so you have to divide by 16.
Okay, and then we have to add one more student.
16.
What's my new mean, Trevor? That's the total amount of centimeters. What's your next step? Do it. Divide by 16. Raise your hand when you have it. Raise your hand when your group has it. Raise your hand when your group has it. Okay, Trevor, what'd you get? 159?
Yeah.
0.56.
0.56.
Okay.
0.565.
So what was our 153? Okay. So what's my new median? How do I incorporate a new data point to my median list?
Just add it on.
Good, Jace. Just add on one more number to the end of your list. Go ahead and tick them off till you get to the middle.
You're missing 2.
Where's the eraser? Put a cap on your marker.
The same median. We have to add those up. And
Cool.
divide by what?
Good. We're going to talk. Why are they adding? What's going on? What are you doing? Why are you adding? Oh, to find the middle? Cool.
We got
146.
Oh, yeah, that's
147. 140.
Okay.
Median 1.
Shouldn't it be 155 plus 155? Divide by 2, what do I get?
155.
Oh, wait, so pause. Okay? This is the aha moment of the lesson. Go ahead and put a cap on it and walk close. Okay, when we had our new person, what happened to my mean, my average?
Went up by like 6.
It went up quite a bit. 159, that's almost 160 centimeters tall. What was our previous average?
53.
153. What happened to my median, my middle number?
Change.
It didn't change. It's still 155 because it switched it over when you had a new middle number.
But they were the same middle number.
So when we had 1 and 2 and we used our data, was the mean and the median an accurate typical height?
Yes.
Yes. Would you say that adding this extreme then kept the mean at a typical 6th grade height?
No.
No. When we added our new student and I found my new median, would you say that's still a typical 6th grade height?
Yeah. So the median was more accurate.
The median is more accurate when you have an extreme outlier. So if this was a dot plot, you'd have dot way out. What happened to your balancing point then?
It
Shifted to the right, or it got higher, right? It increased. But my median was still a very accurate picture. On the next activity, you're going to be looking at 6 different histograms and dot plots. We're doing this as whole group. Okay, so I really need you to listen because people freak out on their cool down. So you're going to be looking at these dot plots and saying, is the mean or the average a good description? Or should I use the median, the middle number, as a typical or good description? So one person go erase, one group member grab the pink cards. Christopher? No. You're going to want to sit at a table with your group. 5, 4, 3, 2, 1. Okay, opening up the cards. Your first job is to look at the distribution and sort them into 2 piles. Okay? Distribution. Okay, so Tyler just made the observation. Go for widespread and narrow spread.
Yeah, but a lot more in the middle.
How is this narrow because it's gapping between white
All right, so wait. Is widespread and narrow spread a good descriptor to sort?
No.
Not really. You almost have just widespread. So then what's another one that kind of sticks out? Give me a card that kind of sticks out. Trevor. A. Let's look at card A. Why does card A kind of stick out? It's widespread, but it's almost like symmetrical, right? My data is evenly, but it comes to kind of a point, like a roller coaster, or we call it like a bell curve, where your data is more like, and it's symmetrical because it's the same on both sides.
Pretty much.
Okay, so maybe that one would be symmetrical. What other one would you deem as symmetrical? Which one? F. Let's look at F. Do you think F is symmetrical, the same on both sides? No. Which one is one that's symmetrical? B?
B.
Look at card B. Does B match this symmetrical curve?
Yes. Went down 5.
Yeah, good. Now, Jay's just explained it. You're not folding it in half because then it wouldn't be. But if you look at just where your data is and you made that symmetrical line on 5, would it be symmetrical on both sides? Yes. So I'm going to put A and B together. What's the other one that kind of matches? It's a little more spread out, but kind of matches this curving line. Jace? C. A, B, and C. Even though C is more like, ooh, it's still somewhat symmetrical. Then we have E, D, E, and F. Look at card D. What's unique about card D? Rylan.
It's got like a big bell drum.
Boom! It's got a high frequency here and then goes straight down. Ah.
It's like weird. Cause like there's two that are just like tall and go down, and then there's just one that's.
Oh, good. We got some gaps, don't we, in E? So it's kind of like E has some higher frequency and then kind of low goes down. We would call that E. What about F? Which one do you think that fits with? Is it more like D or E?
like D.
Okay, so D and F kind of go together. E is that same idea, but it's a little bit lower. All right. Now is the more important part. We're going to go through each of these cards, and we're going to determine what is a typical age and a typical number. So looking at card A. Everybody look at card A. What is a typical age of the dogs being treated at this hospital? What do you think, Trevor? 8. How many people agree with 8? What's your mean? What's the average?
7.8.
7 and 8/10. What's the median? Your middle number?
8.
8. Do you think both the mean and the median are pretty accurate?
Yes.
Yes. And notice that when it's a curve like this, we said both the mean and the median could be used to describe this data set. Let's look at card B. Card B says, what's a typical number of people in the Irish household? Go ahead and look at it. Drayton, what's a typical number of people in the Irish household?
5.
How many people agree with 5? Okay. Look at your mean and look at your median. What do you notice? Give me an observation. Look at your mean. Look at your median. What do you notice? Are you guys looking at the same cards? Yeah, Brendel can't see it. Sit, get with your group. You should have the card in between you so they can actually look at them. Isabel, what do you notice about my mean and my median? They're both 5. So would both the mean and the median and just looking at the data be a good typical description? They both are 5. All 3, if you just looked at it, if you said the mean, and if you said the median, they're all 5. Excellent. What about the next one? Card C. Card C is asking, what is a typical travel time for the New Zealand students? Ooh, it's a little more widespread, but Aubrey, what do you think? 12.5? Yeah? You agree? How many people said 15? Okay, because why? It had the highest frequency. Okay, now, just so we can talk about it, is the highest frequency 15 pretty close to the approximate minutes and the median minutes? Yeah, they're really close. They're 3 minutes off, but we would still say that's pretty close as opposed to 3 and 24 as your extremes. So again, when your data is a bell curve or just a low roller coaster, we would say that the median and the mean are good descriptors. Now let's look at D. D, E, and F are kind of way out there wild cards, and let's talk about them. Would 15 years old be a good description of the typical age of people who attended the birthday party? 15 years old. Give me a thumbs up or a thumbs down. Oh, we were doing so well. Brendel, why do you think 15 years old would not be a good description?
Because I'm not really, I know that I'm the highest frequency.
Okay, so we have a high frequency where? About 7? Maybe 8. Okay, so when we had that high frequency right there, would you agree with the median then? The median was a better indicator. Why was my mean higher or greater than the median? What happened? Okay, wait, Tyler, what happened to my mean to make it 15 years old?
There's that one out at like 40 and 40. Out at 40 and 45.
Yep.
That's gonna affect the median. So it's gonna shift. So it's gonna shift, or the mean. So it's gonna shift.
Who do you think those people were? The parents, probably. Maybe an aunt at that 35 mark. So I hope not grandma and maybe grandma and grandpa at 45. Okay, I'll give you that. Okay, so what happens with those averages when I have a small cluster as an outlier? What happens with my bouncing point? It moved. Yeah, and it's kind of a little bit higher than where it should be. So the median was, switch that. Our median was less than our mean because those outliers pulled it further down. Card E. What are we looking at? Card E. Students going to South Africa to travel to school. So is 15 or 24 minutes a better description? Which one do you think? 15 or 24? 15. I'm hearing 15. Trevor, can you explain why 15 minutes would be a better indicator? Good, I like it. It's kind of split in the middle of my data. I have more of a cluster at 5 and 10 to pull it that way, to where the median is a better indicator because those outliers are pulling my average. Let's look at card F. This one cracks me up. Ages of 40 people on a field trip to Washington, D.C.
60 years old.
Would 21 and 3/10 years old be a good description of the people who went on this trip?
Maybe. Yeah.
Probably. I mean, it's around 20, and 20 is what part of your highest frequency?
Yeah, I would say 21.
Okay.
15.
So, would 15 or 21? Okay, so my typical is between 15 to 20, right? That was the range on my histogram, between 15 and 20.
Yeah.
Why is it hard to tell on a histogram who's closer to 15 and who's closer? There's ranges. So I don't know if the majority of those 30 people are 15 or if the majority of them are 20.
19.
Or 19.
Or 18.
So I could see how you could argue that your mean or your median would be appropriate on this one.
As long as it's close to that range.
Okay, as long as you're careful and you look at that range. Okay, makes sense. A little confusing. Okay, so how did we decide measure of center for dot plots or cards A through C? What did we use? Which one was a good indicator? Both. Both were good indicators. What about D through F?
Well, F was mean or median, but D and C were, or D and E were median.
Okay, so median, we could go with median, possibly the mean on that one. Do you see the difference between these cards?
Yeah.
Okay, when your distribution is more symmetrical, like that bell curve that we've talked about, you can use either or, the mean or the median. But when you have one side, they call it skewed. Skewed data, where you're heavy on one side or you're heavy on the other side, then your median's probably better. Okay, go ahead and put those cards nicely in your plastic bag. Be nice to the cards, yes. Don't fold them. All right, looking at your notes. Okay, looking at your notes. They're blue. Both the mean and the median are ways of measuring the blank of distribution, the center. We also talk about measuring spread or variability, but these two measurements measure center. So looking at where my data is focusing around. Then you got to look up here. So it says, when dot plots show numbers of stickers on 30 pages, the mean number of stickers is 21, marked by a triangle, and the median is 20 and a half, marked with the diamond. The mean tells us, what? They're very close together, good. So the mean tells us that the number of stickers were distributed so that each page had the same, each page would have 21. We could also think of 21 as the balance point for our data. The median tells us that half the pages have 25 and a half stickers, and the other half of the pages have less than 20 and a half stickers. In this case, both the mean and the median could describe a typical number of stickers on a page because they are fairly close together and to most of the data points. What do you think the next one's going to show?
The one of where the mean works, or where the median works, or where the mean works.
All right. Here is a different set of 30 sticker pages. It has the same mean as the first, but the median is closer to 23. What do you notice also about your data? Is it centered?
Bell curve. It's also still close together.
Kind of close together, but what, Nora? It's got a little bit of a bell curve, but if I look at where my data starts and where it ends, is it centered or is it skewed? Yeah, so it's skewed, and we call this, is it right skewed or left skewed? Is it skewed on the right side or is it skewed on the left side? Left. It's more heavy on the left. It's left heavy. In this case, the median is closer to where most of the data points are clustered, and therefore a better measurement of center. Right there. You can also tell, like last week or 2 weeks ago, we did highest frequency. Would that be an accurate description, highest frequency? Yeah, my highest frequency is right here, and that was also the median.
Right side.
What?
Left side.
Oh, my bad.
Yeah, it's
I can't tell my left from my right. I had papers in my hand, so I couldn't do my left and my right.
You also like face get backwards.
I could be like one of those, you know how when you're watching a video and they're like, move to the right, and like you're supposed to go to your right and they're supposed to go to their right.
But
But you can.
But it's like a mirror.
You follow
I just follow them. I'm like, I don't know, I'm just gonna follow you. It's easier for me. So, in general, when a distribution is symmetrical, meaning same on both sides, then the mean and the median values are close. But if it's not symmetrical, roughly symmetrical, then the values seem to be a little bit further apart. Clear as mud?
Mm-hmm.
Awesome. We're gonna do your cool down together.
Oh, yay.
Even together.
All right. For each of the dot plots or the histograms, predict if the mean is greater, less than, or approximately equal to the median and explain your reasoning. So underneath heights of 50 basketball players, would we say that the mean, the average, is going to be greater, less than, or approximately the same as my middle number?
Approximately the same, because it's got that bell curve.
Okay, it's got the symmetrical bell curve. So we are going to write down that the mean and median are about the same. I would write it right underneath the graph so you know which one goes with which. The mean and the median are about the same. Stay after. Okay, next one. Would we say that the mean, the average, is going to be greater than or less than the median? Where do you think the middle value is? Yeah, Rylan? Yeah, I'd say our median, our middle value is going to be about 3. What do you think your average is going to be? What about your mean? Rylan? Yeah, it's going to be a little bit greater because that person that's bringing home the 16 kilogram backpack is totally throwing off my average. So the mean, right, the mean, is going to be greater than the median. What do you think about the 30 people at a party,
The mean
family dinner party?
I feel like the mean's gonna be less than the median this time because your median is gonna be over by 40 and 45, and then your mean is probably gonna be somewhere around 20 or 30.
Excellent. Your mean, in this case, is going to be less than your median. Your mean is actually going to be less than your median. All right, so which one's going to be a better description of center, mean or median for the first one? Both. Good. What about the mean or the median for the backpack weights? The median, the middle value. And what about the mean or the median for the 30 people at the party? Median. Excellent. Go ahead and put that away. Nice job.